Hello, everyone. Today I'm going to go through a little bit of the Chapter 6 review. I don't want to go through all of it. It kind of defeats the purpose of having you practice on your own and trying to put things together. So I'm going to go through some of the questions, some of the ones that focus on the more conceptual pieces. If the question just requires you to put something into the equation, I'm probably going to skip it. I'll go through one or two, but if it's simple plug and chug, then I'm not gonna worry about it. I'm gonna leave that for you. Practice using the equations. Okay. Number one says if an object is not moving, what is its momentum? Well, before we can answer that question, we need to know what is the momentum equation in the first place. So if you go back to the slides, momentum is equal to mass times velocity. So P is momentum, M is mass, V is velocity. So P equals m, that's times v. Okay, green is a bad color, so I will switch. But p is equal to m times v. If an object is not moving, what is v? V is equal to 0. And if v is equal to 0, anything times 0 will make p 0. Okay? So if an object is not moving, the momentum is 0. Okay, a nice big donut. Okay, if something is not in motion, that means it does not have velocity. If it does not have velocity, it does not have momentum. Okay. Two. Two says if two objects have equal kinetic energies, must they have the same momentum? Okay. Two objects, same kinetic energy. Do they have to have the same momentum? The answer is no. Even if they have the same kinetic energy, they do not have to have the same momentum. And let me give you an example now. There's actually one I was looking at earlier that will prove my point. So that is no. What is it? Was it 10 times? There was an example earlier that I was looking up to make sense of this. And here's an example right here. So you have a bullet with a mass of 10 grams and it's going at 1,000 meters per second. Okay. So if we have, remember, kinetic energy is 1/2 mv squared. So if you do 10 times 1,000 squared and divide that by 2, you'll get a number. If you take the Bohl's value, which is 400 kilograms, and multiply that by its number, you'll get a value. Remember, you have to convert everything to kilograms. So 10 grams in kilograms would be 0.01. So 0.01 times 1,000 squared divided by 2 should give you 5,000. 400 times 5 squared divided by 2 will also give you 5,000. So both the Bohl and the bullet have the same kinetic energy. It's 5,000 joules. But if you multiply the masses by their velocities by themselves, so if you do 0.01 times 1,000, you'll get a different number from 400 times 5. So the kinetic energies are the same, but one has a momentum of 10, the other one has a momentum of 2,000. So the Bohl has a lot more momentum than the bullet does, even though it has the same amount of kinetic energy. So if two objects have the same kinetic energies, must they have the same momentum? The answer is no. They do not have to have the same momentum. And that has to do with mass. The only time two objects with the same kinetic energy will have the same momentum is if they have the exact same mass. If they have different masses, then the momentum won't necessarily be the same. Momentum relies on mass and velocity. So, and remember, in kinetic energy, the velocity is squared. That's the big difference. Okay, but in momentum, they're equally weighted. Okay, so in kinetic energy, velocity has a bigger weight. Velocity has a bigger weight because it's squared. But in momentum, the mass and the velocity, neither of them are squared. So they both play equal parts. So because the ball's a lot bigger, and it's gonna have a lot more momentum. Okay, so that's it for number 2. And then number 3, gymnasts always perform on padded mats. Use the impulse momentum theorem to describe how these mats protect athletes. Okay, so go back to your slides. Go back to your slides. What is the impulse momentum theorem? Impulse momentum theorem is this. It is saying that the force times the change in time is equal to your change in momentum. Okay, so basically this goes back to this equation right here where F is equal to delta P divided by T. So this is the impulse momentum theorem. So in this case, we want to get force by itself. So we want to have this. This is the form we want to look at it in. F is equal to delta P divided by delta T. Okay, that's what we want to look at. F is equal to delta P. Remember, the triangle means delta, which means change in. Delta P divided by delta T. And how do the padded mats actually protect us? So what this equation is saying, okay, remember when we looked at the brake example? Okay, when we went through these slides in the previous video, we talked about stopping distances and brakes. If you slam on your brakes, and let's say we're going 25 miles an hour, you can go from 25 miles an hour to 0 by either slamming your brake or you can do it gradually. Momentum is mass times velocity. So if we're going from 25 to 0, this triangle P, this delta P, is going to be the same in both situations. What's different is the T. So if we're slamming on the brake, the delta T is small. A small denominator will give us a bigger F. If we slow down gradually, that'll make the T longer. A larger denominator will give us a smaller F, okay? So if you do it more gradually, you experience less force, okay? And you guys all know this intuitively. If you slam on the brake, your body's gonna wanna fly forward, okay? So what do the padded mats do? What it does is that it increases the slowdown period, okay? As the gymnast falls into the mat, it's squishy, okay? It's like a pillow, okay? It can be compressed, okay? That compression slows down the gymnast over a slower amount of time, over a longer amount of time. I'm sorry. So it's the equivalent of either falling on concrete or falling on a mat. Okay, falling on a mat is going to hurt less because of exactly this. Okay, concrete has no give. If you fall on concrete, you're going from whatever speed you were going to 0 instantly. And that's why it hurts so much. If you add the pads, it disperses the force a little more and it increases that delta T so that you feel less force. Okay. So that is how the mats actually protect us. Okay. And that's what they're doing. They're increasing the time it takes for us to slow down, which in turn decreases the amount of force that we experience. That's what the mats are doing. Okay. I'll leave number 4 for you. I don't want to do all the thinking questions. I want you guys to try to work yourselves through it. And the rest of these appear to be math related questions. And 8, I will leave 8. 8 is a nice thinking question. I'll leave that for you. So the rest of these are just plug and chug. Let's do 2 plug and chug questions. Okay. So number 7. 7, we have a 0.15 kilogram baseball moving at 26 meters per second. And it is stopped by a catcher who exerts a constant force of negative 390 newtons. So the reason it's negative is because it's opposing the ball. Okay, the ball is coming towards the catcher. The catcher has to put a force in the opposite direction in order to stop it. That's why it's negative, if you're wondering. How long does it take to stop? How long does it take this force to stop the ball? So in this unit, in this chapter, we've only learned 3 equations. We learned the kinetic energy equation, 1/2 mv squared. We learned the momentum equation, which is m times v. And we learned the impulse theorem. The impulse theorem is the one we were just looking at. F is equal to delta P times delta T. This is the only equation that has time in it. So just know that this is the equation we have to use. So in this case, we're looking for T. So to get T by itself, we need to do some rearranging. After you do said rearranging, you are going to get that T is equal to, that's an ugly T, but it's T. T is equal to P divided by F. So what we need to figure out is the P. So P is mass times velocity. The mass is 0.15, the velocity is 26. So the answer to this question is you're going to get T is equal to 0.15, because remember P is m times v. So this is 0.15 kilograms times 26 divided by 390. Okay, you can't have a negative time. Okay, there's no such thing as a negative time. Plug in these numbers, you'll get your answer. That's how long it took to stop the ball. That's it for number 7. Just use the equation, rearrange it. That's the impulse theorem. I want to do one from each. So this covers impulse theorem. This one asks us to calculate momentum. That one's a little simple. Or the other ones? Okay, let's do this one. So in this case, we're being asked to find what? We're being asked to find velocity. This is our final destination. What are we given? We're given the momentum, which is 6.17, and we're given the mass. Look at your units. Do all the units match? Do we have to do any rearranging? We have kilograms here, we have kilograms here. Cool. And then we have meters per second here. So when we find our velocity is going to be in meters per second. So what equation should we be using? Again, we have the kinetic energy one, we have the impulse one, and we have the momentum one. Which one has velocity in it? All 3 of them have velocity in it, but which one has everything that we have here? We're just looking for velocity. We have a mass and we have a momentum. So we should just be using the P is equal to mv equation. So P, which is momentum, is equal to mv. We need to give V by itself. If we give V by itself, we get that V is equal to, we got to get rid of the M. Right now we're multiplying. The opposite of multiplication is division. So we give V is equal to P divided by M. What is our P in this case? Our P is 6.17. And what is our mass? Our mass is 0.147. Put that into a calculator, you will get a number. And I will do one more. I will do this one because this one looks like it focuses on elastic and inelastic, and I like those. So let's do this one. So what type of collision are we working with here? Keyword right here. Stick. The cars stick together. If the cars stick together, we have a inelastic collision. Okay? we have an inelastic collision. For inelastic collisions, momentum is conserved, kinetic energy is not. Okay, remember that. So what are we being asked to find? We are being asked to find the velocity before the collision. Okay, we're being asked to find the velocity of a car before the collision. Okay, I'm going to call the first car car 1. So the 1,550 kilogram car, that is car 1. I'm going to call the 2,550 kilogram car 2 for our purposes. Okay. So this is car 1, this is car 2. The cars stick together and move as a unit. So remember for this, you want to remember that because if momentum is conserved, that means the initial, I'm going to use NIT for initial because I don't have that much space. The initial momentum has to equal the final momentum, okay? Now, what is the initial momentum? The initial momentum is the sum of the momentum of both cars separately, okay? So we have M1 times V1I, okay? Remember the I is for initial, this is the velocity before the collision. So M1 V1I, we know M1 and we know V1I, it tells us this, okay? And now, we got north and south, right? Okay, so quick question. If this is going south, that means the V1I, is it going to be positive or is it going to be negative? Remember, we call south negative. So when we plug this number in, just know that that should be a negative 10 because it's moving south. Okay. And then we got to add to it the momentum of the second car. So this would be M2. I don't know why drawing twos is so hard. Okay, M2 V2I. Okay. And this is actually what we're looking for. And matter of fact, I'm going to make it a different color just to make it obvious that that is what we are looking for. Okay, V2I. That V2I is what we're looking for. It says find the velocity of the 2,550 kilogram car before the collision. So we are looking for V2I. Okay. This has to equal, after the collision, it says the cars stick together. If the cars stick together, that means the new mass, or M3, is going to be the sum of both. So this is M1 plus M2. So pretend they make a new object. They collide, they crash, and they're a new object now. They're M3, where M3 is equal to the sum of both of them times whatever their final velocity is, VF. And it tells us that their final velocity after the collision is 5.22 north. Okay. So then you have to do some rearranging, right? So we need to get V2 by itself, and I'm going to continue down here at the bottom. After doing some algebra, after doing some algebra, we get that V2I, okay, V2 initial is going to be equal to, and let me change this back to red. You have M1 plus M2 and VF. We need to get rid of this before we can divide by M2. So I need to subtract this over. So this is minus M1 V1I. And then that whole thing needs to be divided by M2. Okay. So we know M1, it's 1,550. We know M2, it's 2,550. We know VF. VF is 5.22 and it is positive. It is positive 5.22 because we are going to the north, okay? We know M1 again, it's 1,550. V1I. V1I is going to be negative 10, okay? So when you plug in this negative 10, you're actually going to end up adding these two numbers together because a positive multiplied by a negative is going to give you a negative number. And then subtracting a negative number is the same thing as adding a positive number, okay? So just know that when you plug those numbers in, these two values, the one on the left and the one on the right, you're going to end up adding them together. And then we know M2 again in the bottom is going to be 2,550. So this is the setup. I'm not going to bother plugging the numbers in. I'll leave that up to you. But this is for number 12. Plug the numbers into this equation and you will get your answer. Okay? So aside from this is the chapter 6 review. Okay? On top of that, you have the study guide that you need to work on. I will leave the study guide up to you guys. Okay, it's just 3 questions. They have some parts A and B and C, so on and so forth. But 3 questions, I will leave that up to you. Okay? But the chapter review was the more challenging one. That's why I focused on the chapter review. But if you have any questions as you go through it, again, you're always more than welcome to ask. And again, you guys can work together. You don't have to work individually. If you want to communicate through however you like to communicate, there's a bunch of different websites that let you do that. You guys are more than welcome to work together. You can ask me questions. Okay. Best of luck and enjoy the rest of your day.